elastically. And this is the buzzword that Amazon has popularized, whereby if your normal steady state is to get a few hundred, few thousand users per day, but once in a while you might get slashdotted or posted on Reddit or something that draws a whole bunch of attention to you suddenly, not only can you go into Amazon's site, spawn a few more machines, and if you've prepared in advance, run duplicates of your web servers in the so-called cloud, you can then do that all automatically. You can set thresholds whereby if Amazon detects that you've crossed some number of users per second, you can have these machines even spawn themselves, duplicating the servers that you actually have so as to handle the load, and then when things quiet down, they power themselves off. And this is really actually quite exciting because the alternative up until just a few years ago was a place that looked a little something like this. So co-location refers to actually buying hardware and then storing it in someone else's warehouse. You could certainly store it in your own warehouse, but there's economies of scale of putting your servers in the same facility that already has cooling, already has power, already has lots of network traffic, already has 24-hour staff to deal with problems that might arise. And so just a few years ago, starting a company, certainly in anything web or software related that needed to scale, meant you would spend tens or hundreds of thousands of dollars up front, rack the servers in a facility like this, though they don't quite look as beautiful as this hallway here, and then you start running your business. And of course, if you have too much capacity, you've overspent. And if you're unexpectedly popular, but you don't have the hardware, it doesn't take seconds to actually buy hardware, have it delivered, install it, configure it, to then scale up. So this is what's really compelling about the cloud. So cloud is kind of one of the most overused buzzwords these days. And really, the cloud just refers to outsourcing your software or your hardware to someone else. But it's this immediate scalability and this elasticity that's been popularized by folks like Amazon that's made it really an exciting place, especially for people starting companies who might on day one need one server, but in a month, a happy month ahead, need 100 servers. You can do that much more easily and pay marginally for it, not huge upfront fixed costs. The gotcha is that some costs can add up. So besides paying for CPU cycles with something like Amazon, what are other computing resources that a smart business person might want to charge you for? Yeah. So memory, so the amount of RAM you're allocating. Indeed, that's one of the metrics by which Amazon bills you. You decide in advance how much RAM you want, rather than they don't bill you per usage per se. What other resources? Yeah?
If you're running processes on your code from behind it.
So running processes on your code, so actually using the CPU cycles? OK. All right. So in Amazon's model, no. So you don't pay for every CPU cycle that you're consuming. You essentially pay for a gigahertz machine or a 1.5 gigahertz machine. And if it sits there idly doing nothing, they still bill you. Whereas if you and you can't go beyond that. You would have to provision more machines. But besides RAM and CPU cycles, so bandwidth is actually a big one. In fact, a few years ago, when for some of my extension and then CS50 course, we started podcasting things, making them publicly available as open courseware, we actually used DreamHost initially. And we signed up for like a $19 per month account, which was amazing. And it gave us like a terabyte or 2 terabytes of traffic per month. The problem is when you're distributing 500 megabyte or 400 megabyte videos and you have many people downloading them, you can tear through a terabyte or 2 pretty quickly. And so our approach to scalability about 6 years ago was to sign up for a second DreamHost account and then a third DreamHost account. And then every time we exhausted our quota for bandwidth, we would just change the IP address to the other account, to the other account. And this was incredibly manual, but it also suggests how expensive this could have gotten if they had been charging us more competitive rates. That didn't work out so well. And indeed now we brought everything back on campus because Harvard has much more capacity and we don't pay for it directly than we would if we were using a commercial web host. What's another resource that you might consume when scaling upward? Yeah. Yeah, so hard disk space is another one. So with these VPSs, with these shared web hosts, you get some number of gigabytes typically. And frankly, that's often quite enough unless what you're really doing is collecting a huge amount of data. If you are a video site, if you are a photo site. But if you're just using MySQL, storing user data, and even logging lots of stuff, text compresses fairly well. So that's a little less worrisome. But another resource to be mindful of. So Amazon charges you for all of these things, typically pennies on the dollar, but it's something that adds up. So if you're actually curious about this, do have some enterprise in mind, if you Google for Amazon calculator or Amazon Web Services calculator, you can plug in some placeholder numbers like I expect 1,000 hits, I need this much RAM, this many CPU cycles, and they'll estimate what your bill might be. All right, so let's now start solving the problem. irrespective of who's hosting our servers, of scaling in general. So there's this notion of load balancing, which thus far in this class certainly we haven't had to deal with. Back in our web programming days, you had one appliance and thus one server, and you had as many clients as you had browser windows open. But this is not necessarily the most scalable approach, because as soon as you start having hundreds or thousands of users visiting your site, even per second, one web server might not actually be able to handle them all. How many hits per second can a typical web server handle from users? Any guesses? Just order of magnitude? The answer definitely depends, but how many zeros are we talking here? Any guesses?
Thousands?
Thousands. OK, so thousands is pretty encompassing. So thousands is a good answer. So you can expect a typical server that has maybe 4 cores or 8 cores, maybe a couple of gigs of RAM, and it doesn't really matter how much disk space. You can assume that it can handle maybe 3,000 hits per second, 2,000, 5,000. Any more than that, then you probably need some slightly fancier hardware. And I say it depends because it, of course, depends what your code's doing. If you have lots and lots of nested loops and things that consume cycles, obviously it will scale less well than that. But that's a reasonable starting point, a couple thousand or a few thousand hits per second. So suppose you get more popular than this and you actually have 5,000 hits per second. Or you have just a couple thousand hits per second, but your code is actually pretty involved. It's doing a lot of analytics. It's storing a lot of data. So each individual server can only maybe handle 500 hits per second. What do you actually do? Suppose you exhausted the resources of cloud.cs50.net or your own appliance. How do you start to scale up so as to handle even more users? Load balancing is going to be the answer. But how? What does this mean? Zach?
Add more machines to the problem and then
OK.
send users to whichever machine is the most good.
OK, good. So if this is a web-based site and we have a web server already, either in the form of the appliance, or assume that your web server is now hosted on some physical box or some virtual private server, well, if you've got twice as many users, just double the number of web servers that you have. So your picture, you might have multiple clients as depicted up here at the top. You might have n servers down at the bottom. So you need some way, some device, some piece of software, generically called a load balancer, to figure out what client should go to which of these servers. Now, how do you go about doing that? How could we implement this black box, this rectangle of the load balancer? And let's just assume, for simplicity, HTTP for now. So user at home sits down at client computer, types in yourwebsite.com, hits enter. What happens? How does that request make it to server 1, 2, or ... n? Yeah? OK, good. So we could keep track of how busy each server is. And how do you want to measure busyness?
How many requests is processing at the same time?
OK, so let's keep track of how many requests each of these servers on the bottom of the picture is getting per unit of time. And whoever has the fewest at this instant will receive the next incoming request. So that seems nice and logical. Takes into account load. So you would think that you would have pretty uniform distribution, not of numbers of users, but of load across servers. So let's now ask the more technical question. How do you go about implementing that? Yeah, Kevin.
Do you maybe measure some objective measurable, maybe processing? I guess CPU usage or memory, and then distribute based on.
Oh. Yeah, so absolutely. So if we didn't want to keep track of a specific number of connections, which might not reflect how much work each connection involves on the server, we could instead look at the more generic load. So how many CPU, what percentage of the CPU is actually being consumed right now? How much RAM is actually in use among those several servers, and then just pick the lowest. That could work as well. So how does suppose that we now have software that someone else wrote that can answer questions of the form, who is the least busy? Or to whom should I send this request? Now let's ask the technical question of how do you route the request from client to server? What does this load balancer actually do? And again, assume the internet. So assume IP, TCP, UDP, whatever you're familiar with. How do you implement this?
connect with.
OK, good. So if this is all over the internet, we're using TCP/IP, and the way that machines talk with TCP/IP is to address their requests to specific destination IP addresses. Why don't we just tell the client directly the IP address of whichever server is currently the least busy? So we need to involve the DNS system for this, right? Domain name system, so that when a client user at a client types in yourwebsite.com. Recall that in the story that you might have that we told in 50, that you might have heard in CS143, there's a DNS server somewhere at the ISP, at the university, whoever's closest to the client that answers queries of the form, what is the